In section 6 of chapter 5, we're going to start on some exponent rules and dividing by monomials. So what you need to know is this. Let's just look at the formulas and then we'll look at parts and pieces and how it works. If you've got a number 2 an exponent over a number 2 an exponent, you're dividing that, and so what you're going to actually do is subtract those exponents. So just like with multiplication and division are backwards from each other. So when we multiplied the same base and we had different exponents, we could add those. Now when we're dividing, we're going to subtract those. Let me show you why that works. So if you have 2 to the 7th divided by 2 to the 4th, this means you're going to multiply 2 7 times. 1, 2, 3, 4, 5, 6, 7. And you're going to put that over 2 to the 4th power, so 2, 4, 6, 2, 4, 6, 8. 1, 2, 3, 4. There you go. Okay, so 4 factors of 2. Now, when you do that, you know that if you've got a factor that's the same on the top and the bottom of a fraction, you can reduce those. So you can reduce these 2's and these 2's and these 2's and these 2's. So now all that you're left with is 2 to the 3rd power on top. And isn't that the same as 7 minus 4 is 3? So you could say 2 to the 7 minus 4 power equals 2 to the 3rd power. So whichever way is easiest for you to understand in your mind, either subtract that or just cancel them out and reduce them. So on something like this, x to the 6th power over x squared, you can do it one of 2 ways. I'll show you both ways, and whichever way makes more sense to you, do it that way. So one way is to say, well, this is x to the 6th minus 2, because that's on the bottom. So 6 minus 2 is 4, so this is x to the 4th. All right? The other way, now if that made sense to you and you're good to go, then kind of tune me out for 30 seconds. So this is 6 factors of x, and this is 2 factors of x. So I can reduce this by saying, oh, I can take 2 out of there and make that just 4 on the top. So now I have x to the 4th. Either of those ways are exactly the same. You're going to get the same answer. All right? So do this one real quick. You probably don't even have to pause because I'll talk long enough that you can do it on your own, right? Okay, here we go. So you can say x to the 8 minus 2 equals x to the 6th power. And if you reduced it this way and said, oh, 2 of these will come out and make 6, you got the same answer. All right? Now let's do that idea here. On here, what you're going to do, you can do it one of 2 ways again. The first way would be to say this is y to the 3 minus 7 power, which is the same as y to the negative 4 power. All right. When we're simplifying, we don't want negative exponents in our final answers. That's not simplified all the way. And if you'll look, anything to the negative power, what that does is that puts that base into the denominator, because we're subtracting that amount of factors from the total that's on the top. So if you've got a negative exponent, that flips it to the denominator. All right? And just as an aside, if you've got a negative exponent on the bottom, that's going to flip it up to the top, because it's going to be the reciprocal of whatever you have. So in this case, this y to the negative 4th is the same as 1 over y to the 4th. Now, if you were doing the other way, if you were canceling, then you figured that out already, because you said, okay, well, there's 3 of them up here that can cancel, and 3 of them can cancel out of there and leave me with 4. Now, when we did that and we have the number on the top, we can just ignore the denominator because anything over 1 is itself. If 1 is in your numerator, you've got to keep that 1 in your numerator. So you would have ended up with 1 over y to the 4th. All right? Little bit of a different twist to it. Same type of thing here. So you've got x to the 6 in the numerator and x to the negative 2 in the denominator. Now be careful with this if you're using the canceling method here, because a negative 2 and a positive 6 aren't going to cancel because they don't match. So what you have to do is you've got to move this negative exponent up into the numerator first. So now you have x to the 6 times x squared. And if you'll remember, if you're multiplying those, you add those exponents. So that's x to the 6 plus 2, which is x to the 8th. Now, if you had forgotten and said, okay, well, if it's in the bottom, I subtract it, that would work too, because you would say x to the 6 minus a negative 2. And minus a negative is plus a positive. So you would have ended up with x to the 8th still. So I hope I'm helping and not confusing you by showing you lots of different ways to do these. Find the way that works and latch on to it, and you just do it that way every time, okay? All right, because now we're going to divide monomials, and what we're going to do, this honestly, this works best if you just think of it as fractions and just reduce those fractions. What you're going to do is you're going to reduce the same when we multiplied, you multiplied the coefficients and then you multiplied the variables. We're going to divide, the coefficients have to stay together and the variables have to stay together. You can't divide one by the other. It's apples and oranges, all right? So in this case, we've got a 24 and a 6 that we're going to divide. And if it works best for you to say 24 divided by 6 is 4, that's fine. Or if you can think of it as a fraction and say, well, 24 is 4 times 6, and then my 6's will reduce, that works also. So now you have 4 in the numerator. And here you have an x to the 5th and an x squared. So you can reduce this by 2. So 5 minus 2 is 3. So you have 4x cubed is your final answer. Are you getting there? All right. So reduce your constant numbers, your coefficients, and then reduce your variables. All right. Let's try with more. All right. It's not harder, it's just more in the same problem. You're doing the same thing, you're just doing the same thing over and over in the same problem. So first, just look at your coefficients, your 16 and your 20. 16, remember, is 4 times 4, and 20 is 4 times 5. So your 4's can cancel, so you have 4 over 5. And what you can do is, as you get parts of your answer, you can even just put them into your final answer so you don't forget part of it. So 4 over 5 is your coefficient. And now you've got a to the 4th on top and a to the 5th on bottom. So there's more on bottom than there are on top. So you're going to end up with a to the 1st power, or just a, in your denominator. And you've got b to the 7th on top and b squared on bottom. So 2 of them will cancel out, leaving you with 5 of those b's multiplied, those factors of b. So we took the 7 minus 2 was 5. So now we have b to the 5th. And then we have c and nothing, so the c stays in your numerator for your final answer there. Okay? One more, if you think you've got it, go ahead and pause me and do it and then come back. All right? Because what we're going to do is the same thing again. First, look at your whole numbers, your 10 and your 24. Let's see, 10 is 2 times 5. 24 is 2 times 12, so that now the 2's will cancel. So I have 5 on top and 12 on bottom, and those won't reduce anymore. My x cube, x cube is the exact same as x cubed, so that's simply going to drop out and be multiplied by 1, so we don't have to put the 1's in there. So x cubed over x cubed cancels out. X squared over y, or y squared over y. So one of them, this, remember, if you don't see it, it's a 1. Y to the 1 power cancels this one down to just y to the 1. So we just have 5y over 12. All right. So far, so good. I'm going to make it just a touch more difficult, but you can do this. All right. Now, we've been reducing fractions with just monomials. If you have a polynomial in the numerator and you're going to divide it by a monomial, it's exactly the same thing, except, there's always an except, isn't there? Except that, just like when you were multiplying with binomials, you had to multiply every part by every part. If you're dividing, you've got to divide every part. So in this case, we're going to split this up, because you've got 24x to the 5th plus 18x to the 3rd, all divided by 6x squared. You've got to divide each of these parts by 6x squared. So go ahead and write it separately so you've got two separate problems that look like just like the ones we just did before. So you've got 24x to the 5th over your denominator, 6x squared, plus 18x cubed over the same denominator, 6x squared. Now you've got two separate problems that look like just like all the ones that I just erased. So you're going to reduce each one separately and then put it together as a final answer. So this 24 is 6 times 4, so that your 6's will reduce. Your x squared cancels and you've got 3 left. So what's left in this part now is 4x cubed. And there's no denominator, so it's fine. We can leave, it's over 1, but we don't have to have that. We can stop there. And then 18 is the same as 6 times 3. So your 6's will cancel. And we have 3 left here. And 2 of these x's will cancel, leaving you just 1 x. So we have plus 3x. So there's your final answer. All right, let's do a couple more of those. I'll make them a little bit more difficult and a little bit more difficult. So write these down and do them with me. 32y to the 6th plus 24y to the 4th minus 48y squared, all divided by 8y squared. And as I write the next one down, you go ahead and try to work that out and get started on it and see what you can do, okay? And I'll write one more problem, and that's all we've got. And then we'll be done. This one is going to use more than one variable. All right. So how far did you get? Did you split them up? Remember, you got to split it up first. And I don't have room to go that way, so I'm gonna have to work downward here. So split up, and each one of these parts of your trinomial is going to get the denominator. So 32y to the 6th over 8y squared plus 24y to the 4th over 8y squared minus 48y squared over 8y squared. All right, next step is just look at one at a time. This looks great big and scary, but now we've divided it up. Just look at one part at a time. This part is easy. This is 8 times 4, and the 8's will cancel. And your y squared reduces down, and this is y to the 4th because 6 minus 2 is 4. So now you have 4y to the 4th is all you have left for that part. And you're done with that part. Now move over to this part and just look at it as one small problem. 24 is 8 times 3, and the 8's will cancel. 2 of these y's cancel, leaving you with y squared, so you have plus 3y squared. And then you're done with that one. Now look at this problem as a separate problem. 48 is 8 times 6. 6 times 8 is 48. Somehow, sometimes they rhyme. They make it easier. The 8's will reduce. And looky here, your y squared will totally reduce, and all you have left is the 6. Don't lose this minus sign, so minus 6, and that is your final answer. And I always like to check it with, once I've done it once before, make sure I gave you the right answer. Oh, good, I did. I like it when I get it right. I don't always. Okay, here we go. Are you up for challenge? Pause it and see if you can do it on your own. You can do this. All right, here we go. Are you back? Did you get it? I hope so. Here we go. First, we split it up. Each part gets the denominator. So 42t7u squared over 2t cubed u. Don't lose the minus sign. Minus 18t to the 4th u over 2t cubed u. Don't lose this minus. 10t over 2t cubed u. All right. Now, 42 is 2 times 21, and your 2's will cancel. You've got t's The t cubed comes down because 7 minus 3 is 4. You following what I'm doing? And you've got u's. Now you can't reduce a t and a u. You've got to reduce only u's together and only t's together. So you've got 2 of them here and 1 of them here. So now you just have 1 on top. So now nothing is left in your denominator. You're left with 21 t to the 4th times u. Move to the next part. 18 is 2 times 9, so your 2's will cancel. You've got t to the 3rd. There's 3 of them here and 4 of them here, so let's just make 1 of them on top because 4 minus 3 is 1. Oh, and the u's are the same, so they'll just cancel. So don't lose your minus sign. Minus 9 left for your coefficient. Do we have any t's left? Yep, 1 t on top and no u's left, so we're done with that part. One more step. One more small part. There we go. The 2 is going to cancel. Oh, whoops. 10 is 2 times 5. And so now your 2's will cancel. And your t cancels. Ooh, this is trickier because the t, there's more t's on the bottom than on the top in your denominator. So you're going to reduce this one down and you're going to have 2 left in your denominator. But remember, in your final answer, you want all of the exponents to be positive. So leave it in your denominator. So this one is going to have something that looks like a fraction, but it's going to have a term, a monomial, in your denominator. So minus 5 over t squared u. And just making sure I've made too many errors, so I have to check them all the time. Yes, that time it's right. All right, so the trick is when you're dividing by a monomial to split that polynomial up, and then each part becomes one of the easy problems that we did at the very beginning. All right, so you'll first reduce the coefficients, so the whole numbers with the whole numbers, reduce those. Then each part of your variables. So each one of the variables separately, the different letters need to be reduced separately. And so wherever the larger exponent is, that's where your final variable is going to be. If your larger exponent is on top, your final answer will be on top. If your larger exponent is on the bottom, then your variable will end up on the bottom of the fraction. All right, good luck. See you soon.